Perfect. So good evening, guys. I will be presenting the paper, the first paper for Journal Club for GCMER today. Now, my name is Balamurali Krishna. I'm a third-year student from Tbilisi State Medical University, which is in Tbilisi, Georgia. The paper that I'm going to be presenting is the association of habitual alcohol intake with risk of cardiovascular diseases. Now, this paper was a conjoint effort, but the lead author was Dr. Kyron J. Beidinger, and it was published in the March of 2022 in the JAMA Network Open Journal. The content of today's Journal Club, we will be discussing about the background of the research, the methods that was utilized in the research, the results, conclusion, and my opinion on the research, that is critical analysis of the paper, and the scope, whether there's any scope for this particular research later on in the future. Now, the background. So the rationale behind the study is the fact that cardiovascular diseases can be precipitated by habitual alcohol intake. Now, it is a factual thing because it has been previously proven via research data. What these authors would try to do is that they wanted to associate certain limits of habitual intake of alcohol with cardiovascular diseases, because USADA, they have an approved measure of how much alcohol a person can intake per week. For men, it's supposed to be 14 or lesser drinks per week, while for women, it's 8 or lesser drinks per week. Now, given this association, they wanted to try and implement a method in order to see if it was effective or not. And that can be considered as one of the rationales behind the study. Now, usually the previous studies all demonstrated a J or U-shaped curve. So people without any alcohol intake or lifelong abstainers also showed almost a similar amount of cardiovascular disease incidence, but intake of probably like a drink per week or maybe 2 drinks per week showed lower incidence of cardiovascular diseases. They were trying to explain why this was the case as well. Now, there are 2 things that kind of limits observational epidemiology. That is reverse causality and the confounding factors. The major issue with a study like this is the ethics and the logistics which goes behind into the observational epidemiology. But utilization of Mendelian randomization, which is a method for overcoming this confounding and reverse causality, help them to aggregate a lot of data in a short amount of time, with bypassing the ethical morality as well. Now, utilizing Mendelian randomization alone can cause a linearity in the graphs that we obtain from the statistical data. But to overcome this, they also utilize something known as NLMR, or nonlinear Mendelian randomization. The methodology. Primarily, it was a cohort study, but it was conducted in 2 different countries, one in UK, one in US. The one in UK was conducted by the UK Biobank, while the one in US was conducted by the Brigham Biobank. You have a primary and secondary, the primary being the UK Biobank. Now, the total participants in the study encompassed 371,463 participants. Now, in the secondary, that is in Brigham Biobank, 30,716 participants were assessed and genotyped. Initially, 500,000 participants, upwards of 500,000 participants appeared for the study from the period of 2006 and 2010. What we're going to discuss next, as the inclusion and the exclusion criteria, help the authors to reduce the number of participants depending on what they're looking for. The inclusion criteria mainly involve the fact that the participants were of European ancestry to rule out any skew of the data, as well as the fact that only individuals with complete genetic data, social data, and family data were allowed to take part in the study. Exclusion criteria. The major one is the missing of genetic data from the genotyping, as well as degree of close relatedness. If for example, 2 siblings showed up for the study, only one was allowed to take part because the data can skew depending on how close these participants are. And subjects with missing outcome data, because some can be already predisposed to cardiovascular diseases, and which is not due to habitual alcohol intake. So they were also excluded out from this study. Now, the study focused on 6 phenotypes of cardiovascular diseases and 10 continuous variables. The 6 phenotypes were hypertension, stroke, atrial fibrillation, stroke, and myocardial infarction, as well as coronary artery disease. The 10 continuous variables that were focused on were systolic blood pressure, diastolic blood pressure, LDL values, HDL values, your total cholesterol values, apolipoprotein A values, apolipoprotein B values, C-reactive protein values, and gamma-glutamyl transferase values. And obviously, a 2-sample Mendelian randomization study was conducted, utilizing a package. Utilizing a package in the software, our software, known as the 2-sample Mendelian randomization. MR-EGGER and MR-PRESSO, these terms are usually the packages which is utilized in the R software in order to reduce any horizontal pleiotropy, especially MR-PRESSO gives you a value which reduces horizontal pleiotropy. So it sees if there are any other confounding factors for the genetic instrument that we chose. Now, talking about MR, we also need to talk about the genetic instruments that were chosen. There were 2 primary genetic instruments which were initially hypothesized that would work for the study, that is AUD-R and AUD-C. AUD-R was selected as the primary, genetic instrument, while AUD-CR was selected as the secondary genetic instrument. So it was more for like a confirmed analysis. In NLMR, that is nonlinear Mendelian randomization, 2 methods were utilized as fractional polynomial and piecewise linear method, which we will be discussing once we get to the results section. The results. What the authors found were the fact that J and U-shaped curves were still followed, even though they did account for confounding factors. And this also reduced the cardioprotective actions of modest alcohol intake. So according to USADA, we could take up to 14 drinks per day, but that was considered to be a modest amount of alcohol intake. But even that is kind of ruled out as per the study. AUD-R, which is the primary genetic instrument, is closely related with alcohol intake. So it kind of ruled out most of the confounders, which were kind of a problem for the whole study. Genetic evidence also supported associations between alcohol use and increased risk of hypertension and CAD. So as I said earlier, AUD-R helped in this hypothesis. And also, in fact, it became a reality because AUD-R helped in identifying the causes which went into hypertension and coronary artery disease with linked of habitual alcohol intake. NLMR better approximated the association between alcohol intake and both hypertension and CAD with a p-value of less than 0.001 for both models. Both of them significant. The reason why I only mentioned 2 of them is because the other 4 phenotypes, the cardiovascular disease phenotypes, stroke, myocardial infarction, atrial fibrillation, and heart failure, all 4 of them didn't have a significant value, only showing significance in hypertension and CAD. They also suggested nonlinear association between alcohol intake and continuous risk factors only for 3 continuous variables out of the 10, that is SBP, DBP, and LDL levels, with all of them with a lower p-value of 0.001. Over here, if you look around, you can see the first graph is a sex stratified graph associating between alcohol and primary cardiovascular disease outcomes. Now, the reason why this graph is important, and I included it in the presentation, is because if you can look over there, in men section, with a 95% confidence interval, the p-value is 0.0010, which is not significant amongst light drinkers. And light drinkers were approximately 57,690 people out of the entirety of the study population. The value kept on decreasing until it reached a significant value until the abuse of drinkers, where the p-value was lower than 0.001. Same goes for coronary artery disease amongst men, where the p-value was initially high but kept on decreasing until abuse of drinkers. What's even more confounding is the fact that hypertension amongst women didn't show any significant p-values, which could lead to the fact that it wasn't a good genetic instrument which was chosen for the study because it did not take into account how women reacted to alcohol or the effects of alcohol in their body. In the nonlinear MR test, what we need to look at is the quadratic p-value and the Cochrane p-value. A lower quadratic p-value suggests that the particular disease follows a nonlinear regression. So for hypertension and CAD, both of them, we have a nonlinear, following of regression. But for MI, stroke, and heart failure, as well as atrial fibrillation, all of them have higher p-values than the associated p-value. And so we cannot say that the test was completely successful. The next one is the Presso value, where we MR Presso sensitivity analysis for the two sample MR, where we checked for pleiotropy, horizontal pleiotropy. And the global test values of this is given over here. What we need to look at is the global test p-value. For hypertension, the pleiotropy is very high, it's 0.285, but for coronary artery disease, it's 0.019. It is still high, but comparatively, it is better. Also, for coronary artery disease, a single outlier was detected. Again, goes to show how the genetic instrument which was chosen for the study was not appropriate. This is for the continuous traits, but that's not of much significance because all the p-test values, except for one, that is LDL cholesterol levels, everything else had a very high p-value for global test value, which goes to show that the rest of the factors were kind of insignificant in the statistical analysis. This is the U and J-shaped graph that you obtain when you do statistical analysis for alcohol consumption and prevalence of cardiovascular diseases. You see how abstainers, even lifelong abstainers, or probably abstainers after consuming alcohol, they still have a moderate amount of cardiovascular disease risk incidence. But it reduces when you take 0 to 10 drinks per, let's say, per month or per week. And it keeps on increasing when your drink count increases all the way up to in between 0.4 and 0.45. This trend is then attenuated with Cox destruction values. That is, the black one is the Cox values, while the lighter ones are the adjusted values. These adjusted values also show that even modest amount or light amount of alcohol intake kind of predispose you to hypertension in men. For women, the same trend is again followed. This is the nonlinear MR analysis of alcohol and total mortality. This is the piecewise analysis, while this is the binomial fractional analysis. The shaded region shows you the variance. This shows a high amount of variance due to a lot of confounding factors, and this is before adjusted. This is before adjustment. This is the polynomial nonlinear MR analysis after adjustment. It shows a much more lower variance, and it clearly shows that there is a trend which follows with alcohol intake and cardiovascular diseases. The conclusion which the authors came to was that light to moderate alcohol consumption may have cardioprotective advantages, but these effects are significantly masked by lifestyle variables. Now, this is very important due to the fact that they only attenuated for 10 variables. If a study is later on conducted, which assesses more variables, that would mean that even the protective advantages of light drinking might completely be ruled out. They were also able to, create an association between alcohol intake and cardiovascular diseases, but it was already created earlier on by our previous studies. Now, my comments on this mainly is the fact that I'll talk about the merits of the study. Now, the merits, they talked about how they wanted to create a link between cardiovascular disease and habitual alcohol intake. They were successful in creating that link. Now, they were also successful in creating the link between modest and light alcohol intake to precipitation of cardiovascular diseases. This was not done earlier in previous studies, mainly due to the epidemiological studies, drawbacks. But utilization of Mendelian randomization, it helped them come to that conclusion. It also, as I mentioned previously, it also mentions that if you take into account a lot more lifestyle factors, it might mean that even light drinking can precipitate cardiovascular diseases. A higher amount of alcohol intake warrants higher risk of cardiovascular diseases. And the public health limit or recommendations of habitual alcohol needs to be reduced from 14 for men and 8 for women accordingly. Now, the demerit of the study, the main demerit is the fact that the genetic instruments that they utilize, the AUD and AUDCR, Both of them are not for habitual alcohol intake. Instead, they're for acute or chronic alcohol intake, which is an extreme abusive amount, because AUD stands for alcohol use disease. Now, it's usually utilized for excessive amount of alcohol intake, but the study was focusing on habitual intake of maybe less or moderate amount of alcohol. Utilization of AUD and AUDCR kind of meant that the graphs were going to skew in a manner where it's going to show that the entirety of alcohol intake is going to be bad for a person's health. So it did not account for the fact that AUD and AUDCR does not account for a low amount of alcohol intake. And also this created pleiotropy, because AUD is also linked with congenital CVD, and genetically predisposed CVD. And this pleiotropy was also not accounted for. And yes, that's pretty much it. Thank you.
Thank you, Bala, for such an informative presentation. Now I would